I highly recommend.
Another 15 seconds or so. 15 seconds. Oh, 15 milliseconds. Oh, nice. Okay, I hope we're able to catch up or find something new about the people around you. You have a new packet. The test, as I said, I haven't finished grading it yet, so hopefully by next time, we'll see how it goes. Before we talk about this, Henry, I'm going to ask you to step out just for a little bit. Henry hasn't taken the test yet, so I don't want to give anything away here, but I want to debrief for just a little bit. And let me pause. I don't need to record this. Let's do it. Not pause. Share. Pause recording. I am curious. Okay, so we are back after debriefing about the test. And now let's talk about the unit. So you've been looking forward to this one. I know. Exponential and logarithmic functions. Yeah, it's here. The day is here. You'll notice that we have 2 quizzes. When I say days 1 and 2, I mean of the unit. So 2 quizzes, and then our test will be March 11th. So you may notice 5.1 and 5.2. We've already done them. Why did we already do this section? Not for the limits. Specifically, so we get to the inverse trig functions, right? So the inverse trig is actually, I think it's chapter 7 in the book, if you're looking at the book. So we need to do this first section before we did that, of course. So we're going to start a little bit differently since I've already technically gone over this with you, and you may know this because for many of you, this is going to be the 3rd time hitting this, isn't it? At least the 3rd time doing composite functions and inverse functions. So today it's going to start with you doing the work. Pages 1 through 7, I'm going to ask you to go through it and just you and your partner, your new partner or partners, do what you can do.
Like every problem.
Yeah, every problem. You don't have to fill in the boxes or anything like that. Just the problems. No, you can talk about it if you want, but do the problems. Do the problems.
Oh, that's what. Wait. There might be. Wait, I could be.
Oh, you're just doing pages 1 through 7 right now. Or 2 through 7. I'll pause this again. Ready or not? Let's see what you got.
Yeah. We'll get to. Yeah.
Okay, so how was it? How'd you feel overall? Not lost, right? Maybe a little bit sleepy. Nico, maybe a little sleepy. I don't know. I want to say that even though I'm going over this very quickly, if you're confused about anything, it is your responsibility to make sure you understand all of it. So either meet with me or look in the book. And if you want practice for any of this, what can you do? If you want more practice, like there's a bunch of problems here, what can you do for more practice?
Yep.
Come to me. I'll give you practice. And if I'm not available, what if it's like 10 at night and you want practice? I'm not going to come to your house. Textbook. I heard in my other classes, some people have never opened the textbook, which I don't blame you, honestly. Like, what's the incentive? Or what's the incentive in this class? It is a great resource. I highly recommend that you take a look. But if you're determined not to open the book, If you're determined not to open the book, at least look at the online edition of it on my math lab. It's all there. It's just a little bit more difficult to navigate, but you could do it. But no excuses. Okay, I don't want to know how you did it. I just want to know what the answer is. For A, Amir, what'd you get? Amir, did you say something? 95. Okay. I wasn't sure if someone else said it or if you did. Okay. Do we agree? Okay. Levi, what'd you get for B?
27.
127. Thank you. Holden, for C, you got 17. And for D, Henry, you got 1. Are we good with these? Okay. Seems like most of them people are not arguing about these. So if you got something different, chances are you did something wrong. Okay. Oh, domain of a composite function. Okay. So this one you can tell it's a little bit imbalanced. Considering the last 4 were pretty quick answers. I want to know what the F, well, what does that even say? Sophia C, what does that say?
Like half of G. So.
Yeah,
Like G.
perfect. So we could say F composed with G, or we F of G of whatever variable it is. And did you get a function for F of G of X? Negative 13 over 3x plus 4, you said? Okay. And
Plus 14.
oh, 14, I'm sorry. Sorry. Okay. Thank you. I misheard. And were you able to get a domain for this?
Like X in 5/2 or negative 14.
Are we good? Nicely done.
Yeah.
Was it positive 14 over 3?
I thought,
Keep it negative.
oh, it's negative. The negative is not going to be minus 1.
Yeah, I got 13 over negative 3.
Yeah.
Me too.
It's not negative.
Oh, if we multiply top and bottom by negative 1, we get 13 over negative 3x minus 14. Is that something that you other people got?
No, I'm saying it's not, it would be plus. I got plus 14. Me too.
I got positive.
Like
Me
13
too.
over negative.
Oh, yeah. You're right.
Yeah.
So is there an issue?
Yeah.
Yes.
So this should be minus maybe?
Yeah,
This should be
Yeah.
minus. Oh, be careful. So then this would have to be 14 thirds. Okay. Or 13 over negative 3x plus 14. What another acceptable answer. So something went wrong somewhere. So make sure to. Okay. Cool. Any questions? If you're thoroughly confused, make sure to do something about it. Not necessarily right now, but at some point soon. This one, show that these are equal. Do you get that these are equal? Thumbs up if you got that they're equal. All right, and what do they both equal, Kimmy? For example 3. Negative 4x, you said? Over,
And
negative 4x plus 3, over 3.
plus 10 or 7 thirds.
Plus 7 like this? Oh, 7 plus 7 thirds.
7 over
7 thirds. Okay. Okay, so good. We could either do it like that, or since it's a common denominator, we could put that negative up here. Are we getting either one of these? Okay, thank you, Kimmy. Nice. It's hard to say these kind of fractions, extended fractions. Okay, example 3. Oh, I already did example 3. I just wrote in the wrong place. I was wondering. I had a little deja vu right there. Okay, there we go. Example 4. Sahana, what'd you get?
So I got 8 plus 5.
5. Are we good with that? I think one more answer.
Or negative plus.
Plus or minus Good. Okay, this one, words. You had to read words for this one. Let's see if you were able to get it. Nico, what'd you do?
Yes, there's a kind of skip.
I gotcha. Well, let's say if looking for C of 3 and 3 is hours. And we're trying to figure out the cost for 3 hours of work or 3 hours of production at this place. So let's see what we can't put it into here, can we? Exactly. First you find n of 3, and then you would put that into C. So it'd be C of n of 3, right? So that's a specific hour. So what do you think, considering that, what do you think we're gonna have to do now? You just did that in your head? Amazing skills. Yeah, perfect. Of course, if this were a test or quiz, you would have not just stopped there. You would have simplified it and understand that you already get pretty good credit by doing this. It is C of T, but I do want things to be simplified. Once we simplify it, it's going to be a quadratic expression. Should we try to factor that quadratic expression? Factoring isn't simpler. Factoring is a tool for you to find zeros. So Nico, thank you. Nice job working on your feet there. Okay, next. Oh, this is a real toughie. Hey, what do you think? Is it 1-to-1? Nope. How about B?
No.
Yep. Okay, I'm not gonna explain that one at all. If you know a continuous function is always decreasing on an interval, can you determine whether it is a 1-to-1 function? Always decreasing on an interval. What do you think? Yes, no? The answer is this is poorly worded. Don't you agree? Why is this poorly worded? Yeah. Eileen?
Always decreasing, but then it says on interval.
Yeah.
Is it always decreasing or is it just decreasing on one interval?
Yeah.
I think you're right. This should be strictly just decreasing. I think for a math mind, like for a math teacher, it means the same thing. Like from here to here, yes, it's always decreasing, but always also implies like forever. But there is one other issue here. Yeah, it doesn't talk about the continuity. That's interesting. I'm not sure it needs to be continuous to be 1-to-1. Interesting idea. Oh, it kind of does. Well, not, it doesn't have to. I like it. There's one other thing. Yeah, interval's a problem. Specifically, okay, so if you know the function is strictly decreasing on an interval, can you determine whether it
It's like 1
is 1-to-1, a 1-to-1 function? Yeah, we don't know how long interval is. So on that interval.
On
Right.
the interval, that's all the functions that that's-
Exactly. Like sine is strictly decreasing on an interval, isn't it? But not always. Yeah, so it's not well worded.
Like that, like without all the corrections, you would say no.
Yeah, without all the questions, there's too many problems. I could accept yes or no. Yeah, there are too many. But the thing is, on a question like that, I would expect some sort of written follow-up, why it's not, why it is, etc. But yeah, is it 1-to-1 function on that interval? Yes, if it's strictly decreasing. Also, if it's strictly increasing, yes, it is 1-to-1. I got to fix that for next year. That's not good. Okay, inverse functions. Okay, help me draw the graph. Eileen, would you help? Thank you. Okay. So -2 becomes, okay,
Zero.
okay. Okay. Then we just connect the dots. And we recognize that these graphs are reflected over the line y equals x. Thank you, Eileen. Okay. Verify that these are inverses by showing, are they inverses? Okay. You check both of them? Okay. I just don't want to belabor the point. Okay. For the one-to-one function, f of x equals x cubed minus 3. Could you visualize x cubed minus 3 in your head even before you graph it? And it is one-to-one? Okay, and because it's one-to-one, we know that it has an inverse. Zach, what is the inverse?
Cube root of x plus 3.
Cube root of x plus 3. Do we agree? Thank you. Zach, keep on going. What's the domain? Well, let's do both of these. I'm gonna make a little table. Did you already write all of these?
Yeah.
Okay, I'll do this. So for the function, the domain is
X has to be above 0.
this true?
All
If, for square roots, it would be above 0. Yeah, so all real numbers are -infinity to infinity. How about the range? I think it's all real numbers. And what should we do for the domain range of the inverse? It's not the same. You have to flip them. But it's the same thing. Thank you, Zach. I'm sorry, there wasn't a lot of excitement in that one. Any questions? Did you graph them? Were they reflected appropriately? Were you satisfied with the graph? Like, oh, it's so reflected. I hope you were able to see that, get that satisfaction. For this one-to-one function, okay. Christine, we're able to find the inverse of this one? No, not yet? Okay, well, help me out. How are we going to start? Nice. So x is equal to 3y over 2y minus 1. Yeah, this one's a toughie. And now that we've switched them, our next goal is to do what? Exactly. And do we agree that this is a little bit of an algebraic challenge until you know like the trick? Christine, would you like to continue to solve for y? Nice. Okay, what do we do next? I like it. So 2xy. I hope you don't mind if I distribute at the same time. Thank you.
Add 5 to the right and then subtract.
You said 5?
Add x.
Oh, okay. Okay.
Y to that.
I appreciate your efficiency there. Nice.
Factor out y. So then it'd be 2x minus 3 is equal to x, and then divide 2x minus 3 to the right. So then it'd be inverse of f of x is equal to x over 2x minus 3.
Ooh, thank you for writing it. Inverse of f. Are we good with this, everybody? Woo! You did it. Nicely done. Thank you. I want some help with the domain and range. Christine, I'm going to give you a little break because you just did some heavy lifting. It would be Sophia S., but alas, she's not with us today. But it is Shane. Help us out with the function. Yeah.
The domain of the inverse, I said that x cannot equal 3 halves.
Can you kind of tell us how you did it as you kind of talk us through this?
Because I said
So you said,
equation is y equals x over 2x minus 3. So
Okay.
the denominator could be 0.
Okay.
And then I said, found what the x value is. And
Yes.
then I found the domain of the other function,
Okay.
which was 1/2, because that's the same thing.
And when you say 1/2, x can't equal 1/2. Okay.
And then I said that the range for the inverse is the same as the domain for the first and vice versa.
Okay. So for the function, we know that the range is y cannot equal 3/2. And for the inverse, I'm happy you went to the y's there. Very nicely done. Do you prefer to do this in interval notation? I like this.
Like that.
Me too. Thank you, Shane, for your help. Any questions here? In your mind's eye, could you see the domain of the function in the graph, right? In the graph of the function, in your mind's eye, could you see it? It is in the form of a vertical asymptote, isn't it? Could you also see the range that y can't equal 3/2? That is in the form of horizontal asymptote. Can horizontal asymptotes be touched though? They could, but not when it's linear over linear. So that it's a nice connection that we could actually see the range right there. Did you graph them? Yeah, it's a little bit hard to see the reflection over the y-axis with all these branches going on. But I trust that you could graph them. If you have a hard time, do something about it. Okay. Okay, this is a toughie. Noah, we're able to get to this one?
Well, I basically just like the domain range for the inverse. So for the inverse, I said the domain is bracket equal to infinity parentheses. And then for the range, I did bracket 5 infinity parentheses.
Are we good? Thank you. Okay, so 7, example 7 on page 7. It seems like a lucky problem. Who'd like to help us with this one? Who got here already? Okay, I'm going to give everyone a chance to talk about this specifically and see if you can come up with it. Only a few people got here.
It's basically
Increasing.
Put over all the white.
Also, 3 from 0 to 5. So that's
Yeah, so it's like this.
Instead of being like.
That's like really.
Zero,
Like, this is my. Wait, no, it's gonna. Because all of like.
so we increasing.
Yeah.
Oh, tower.
It could be like this.
Try drawing.
Okay. Was anyone able to get anything? Nothing? This is a little bit of an extension of concept, isn't it? It's definitely not clear cut like some of the other ones. Any ideas on how to do this? Eileen, you have an idea?
Like, well, whatever that's to be.
Okay.
So, 0.5 is increasing, so it's like 5.
And did you keep it in the first quadrant? Did you start at 0, 0? Do you mind if I start up here and maybe do something like this? So does that kind of look like yours at all? Is it? No? Okay. Thank you. So, but let's say that I did this. So are you okay to apply what you were thinking to this? Okay. Why did you do that?
Like flipped over that axis,
Okay.
so then. It would be same.
On the what?
From 0 to 5 y, the inverse.
Okay, nice. So like this, if we say this is a 1 right here, that means that we're about to go to 1 comma 0. And then something like this. So increasing from 1 to 5 and look at the y's. Do we agree with that? Nice. Do we know what these x values are? I think the first one might be f of 1, and the last one might be f of 5. It's turned around, isn't it? Because it's inverse functions. But the function, I think the whole point is that if you start with a increasing function, then take the inverse of it, you're going to get a function that is also increasing. Eileen, thank you for your help with that. It's increasing. That's enough. Okay, so I'm going to tell you what's going to happen for the rest of today, because our next section is everyone's favorite. Yeah, exponential functions and logarithms. Okay. Have you studied this before? Do you remember this? To varying degrees, I imagine. Some of you are like, I got this. Let's do some logarithms now. Some of you may not be saying that at all. So if I could get your attention just about this next section, what we're going to do is it's also going to be a little bit different. Like today, I didn't introduce anything. I'm not going to introduce anything this time, but I'm going to say that your homework is to do the problems as many as you can from 5.3 and 5.4 in the packet. It's not going to be online. But don't spend more than an hour. Also, please do not go and get a tutor if you are having a problem with this. Don't spend a ton of time trying to figure this out. I'm going to talk about it next time. So do what you can. You'll have the next 20 minutes in class, which means you have, have 15 minutes in class or 45 minutes at home. Up to that, you have some time to get started on that.
It's okay, show me one.
Oh, yeah.